By the end of this module, you should be able to define geothermal source heat pump, identify the main components of geothermal source heat pump, and explain the unique components of geothermal source heat pump.
Geothermal heat pumps, also known as ground source heat pumps, are highly efficient heating and cooling systems that use the stable temperature of the Earth's subsurface to transfer heat between the ground and the indoor space. GHPs leverage the principles of refrigeration to provide both heating and cooling by circulating a heat transfer fluid through underground loops. They are a sustainable and energy-efficient choice for residential, commercial, and industrial applications. A water source heat pump is a complex system consisting of several key components working together to transfer heat between indoor and outdoor environments. Let's explore these components. Evaporator, condenser, compressor, expansion valve, piping and tubing, sensors and control systems, and oil. Geothermal heat pumps has several key characteristics that make them an attractive choice for heating and cooling. High energy efficiency, steady performance, environmental sustainability, quiet operation, and longevity. High energy efficiency. Geothermal heat pumps are renowned for their exceptional energy efficiency, as they can provide more heating or cooling energy than the electrical energy they consume. Steady performance. Geothermal heat pumps operate consistently throughout the year, as the temperature of the Earth's subsurface remains relatively stable, providing reliable heating and cooling. Environmental sustainability. Geothermal heat pumps produce minimal greenhouse gas emissions and rely on a renewable and stable heat source, the Earth's thermal energy. Quiet operation. Geothermal heat pumps are known for their quiet operation, with no noisy outdoor condenser units. Longevity. Geothermal heat pumps often have a longer lifespan than traditional HVAC systems due to their reduced wear and tear. In addition to the key components, some geothermal heat pumps may incorporate unique components or features designed to enhance their functionality and efficiency. These unique components include flow center, desuperheater, and buffer tank. Flow center. The flow center is a critical component that controls the flow of the heat transfer fluid between the heat pump unit and the ground loop, ensuring efficient operation. Desuperheater. A desuperheater captures excess heat generated during the cooling mode and can be used to preheat domestic hot water, increasing energy efficiency. Buffer tank. A buffer tank stores heated or cooled water from the geothermal heat pump system, ensuring a consistent supply to the heat distribution system and reducing the frequency of geothermal heat pump cycling. Here is the list of advantages of the geothermal source heat pumps. High energy efficiency, environmental sustainability, steady performance, quiet operation, longevity, versatility, and zoning capability. High energy efficiency. Geothermal heat pumps are known for their exceptional energy efficiency. They can provide more heating or cooling energy than the electrical energy they consume. This efficiency leads to reduced energy bills and lower operating costs. Environmental sustainability. Geothermal heat pumps produce minimal greenhouse gas emissions because they use the stable temperature of the Earth's subsurface to transfer heat. They rely on a renewable and stable heat source, the Earth's thermal energy, which makes them an eco-friendly choice. Steady performance. Geothermal heat pumps operate consistently throughout the year. The temperature of the Earth's subsurface remains relatively stable, providing reliable heating and cooling. They are not affected by external weather conditions, unlike air source heat pumps. Quiet operation. Geothermal heat pumps are known for their quiet operation. There are no noisy outdoor condenser units, making them suitable for residential and commercial applications where noise is a concern. Longevity. Geothermal heat pumps often have a longer lifespan than traditional HVAC systems. With fewer moving parts and reduced wear and tear, they require less maintenance and offer long-term durability. Versatility. Geothermal heat pumps can be used for various applications, including space heating, space cooling, and domestic hot water heating. They can provide multiple heating and cooling functions from a single system. Zoning capability. Geothermal heat pump systems can support zoning, allowing different areas or rooms in a building to be heated or cooled independently. This enhances comfort and energy savings by only conditioning the spaces that are in use. Here is the list of disadvantages of the geothermal source heat pumps. High initial cost, land space requirement, complex installation, system design challenges, and maintenance needs. High initial cost. The installation of a geothermal heat pump system, including drilling or excavating for the ground loop, can be expensive. The high upfront cost may deter some homeowners and businesses, despite the long-term savings. Land space requirement. Geothermal heat pumps require space for the ground loop installation, which may not be feasible for properties with limited outdoor space. Vertical loops may be necessary, which can be more expensive. Complex installation. The installation of geothermal heat pump system is more complex and specialized compared to traditional HVAC systems. It requires experienced professionals and specific geological considerations. System design challenges. The design of the ground loop system must be tailored to the specific property, taking into account factors like soil conditions and available space. This customization adds complexity to the installation. Maintenance needs. While geothermal heat pumps have lower maintenance requirements than traditional systems, they are not maintenance-free. Periodic checks and servicing are necessary to ensure the system's continued efficiency and longevity. So, just like a team, these furnace components work together seamlessly to ensure our homes stay toasty when we need it most.